Hi, everyone. Thank you all for being here. We have the pleasure of having Vaclav Pech with us today. Vaclav is keenly interested in server-side Java technologies, distributed and concurrent systems, modern programming languages, and DSLs. He has joined JetBrains on a mission to empower developers with top-notch development tools, and is currently involved in the MPS project, developing a projectional DSL workbench and building customized DSLs. His tutorial will be on MPS. So Vaclav, the floor is yours. Thank you.
Thank you, Nuno, for introduction. I hope everything will go smoothly. Welcome everyone to this tutorial. I'm happy you joined me at lunchtime for, I guess, most of you. We've got 1.5 hours to go through the basics of JetBrains MPS. So my goal is to start from the basics, because I can't really assume any prior knowledge of MPS that you might have. But this is not a hands-on tutorial, so we can progress pretty quickly and get into interesting areas. So not only to cover the very basics, but we can get to things like the IDE support. We might get to language versioning and things like that. I want this tutorial to be practical, so I'll be showing code. I'll be doing stuff myself here. But as I said, it will not be hands-on. You can't really learn the things here, but the tutorial, I'm pretty sure, I mean, the main goal that I want to achieve here is to give you a head start if you decide to learn MPS at some point. So you will already have known all the basic elements, and so learning MPS by yourself, if you ever decide to do that, will be much more easy than without this tutorial. So that is my goal. Hopefully we'll be able to achieve that in this online setup. Okay, so I decided to divide this presentation into roughly 2 parts. In the first part, I would like to illustrate the possibilities, what the tool can actually do, show you some examples of languages that were designed with MPS, so that you can see the capabilities of the tool. In the second part, then we'll go hands-on with building some simple language extension and playing with it a little bit more to try various things with that extension. So now, some of you might know MPS already. Some of you might have actually tried it out. Maybe some of you have done it a long time ago. Things have changed in MPS, so there might be things that are now different than they used to be when you saw MPS the first time. What stays the same is that MPS is an open source language workbench for domain-specific languages. So it's a tool, it's an integrated environment where you create a domain-specific language or set of languages, and also a tool in which you use these languages to write code. Alternatively, you can use MPS to actually create an IDE specifically for your domain-specific languages, so that you can distribute your languages packaged in an IDE that is dedicated to those languages. Actually, I would like to illustrate the possibilities first on a very simple example. So a very simple domain-specific language that serves a particular purpose in a particular domain, so that I can illustrate, and you can see the capabilities and the purpose of the tool. And along the way, I might explain some fundamental concepts that we will need later on when explaining how MPS actually works. So this is more to set the expectations and set the terminology from this tutorial. So the example I chose is an Ivr system, so a system that you can use to define automatic responses for a phone response system. So in your organization, you might have a server answering the phone calls and then giving the people that call, giving them the options like press 1 to get invoices, press 2 to talk to technical support, press 3, and using the phone you navigate through a menu and eventually you get the answer, the information you need, or you talk to a person that can actually help you. Now, there are several systems out there that support such such services. I chose Asterisk as one of the technologies that as a target platform. So if you use Asterisk, this is the format of the menu configuration. So it's a textual file and some audio files that you upload to the server, and the server will then use it to actually answer the phone calls. And as you can see, this is a fairly technical format, so you definitely need IT people to work with that format. On the other hand, typically you have people from the customer relationship or from marketing departments to be in charge of the voice menu and the structure of it, and the initial design, and then the maintenance, and then perhaps updating it with the recent marketing campaigns. So so you need two people, at least two people, to work on that. You've got the marketing people, and then you have the technical people, and they have to cooperate. So that's a typical sort of setup for software development. But however, with the right modeling tool, this can perhaps be made better. We could perhaps remove the need for an IT person to be readily available whenever the menu is to be reconfigured or changed. And that was the purpose of the modeling tool I want to show. I want to show now. So, well, here it is. So here is a tool built with MPS. So this is not MPS itself. This is a tool built with MPS around a set of fairly simple set of languages that are meant to make the task of creating voice menus easy for people who are not really technical people. So what you can see is an editor here, which shows the structure of one of the menus that our organization might be using. And so here's a little menu. You press 1, you get the products. You press 2, you get the technical support, and such. And the editor is interactive, so there is tooling based in that editor. So you can press a keyboard shortcut to get to the definition of that technical support menu and see what's in there. You can obviously hit enter and start editing. If you mistakenly enter a number that is already present in the menu, you get an error. An error that is domain specific. So it's telling you on the level of the domain in which you work where the problem is. So it's not a technical low-level error that would be reported at runtime, but it's edit time domain level error reported here. And you've got various suggestions like the numbers that are not taken yet. Then you can create an activity, and you give them the option to actually set it up. So now you can set it up, and you've got a completion menu here where you can select the activity you want to enter, or you've got this right side menu where you can pick the thing you want to insert. And also you can unit test your menus. So unit testing is a very a very important activity that not only can help programmers, but it can also help other users of languages, even domain-specific languages, to increase their confidence in their models. So for this particular simple language that defines menus, I came up with a testing language that allows you to specify the buttons you press on the key on a phone, and then you can make assertions about the parts of the menu that you navigate to using this sequence So here's one of the tests that verifies that, for example, pressing 1 and 2 leads to this menu, and then continuing with 1 and 2, you get to detailed description of the MPS product, and you can run the test, and the test is interpreted against the model and evaluated, and you've got the assertions here telling you whether you succeeded or not. So if I insert some valid number here and run the test, I get a failure telling me that in this menu there's no option defined for the number 9. Well, if I use 3 and run it, and obviously we get a failure here where the expected menu entry differs from the one to which the interpreter actually got following our commands. All right, so to wrap it up, what we've seen was a domain-specific language that is targeted from one particular domain, plus it has tooling built to it. So tooling like code completion, intentions, error reporting, there might be refactorings in there, and testing, and also version control. Obviously, the models, the menus you've seen, they can be versioned in Git, and you can have branches, and all those bells and whistles that are very important for usual software development. You can have it also for domain-specific language development. And obviously, that's not the end of the story. Now, the models have to be useful somehow. So there is a generator associated with that language. Well, here's a schema explaining that. So we've got a language for voice menu definitions that the people from marketing can use to create their models. The language comes with a generator that can be used to actually transform the models into some generated code, and that generated code, in our case, is a textual configuration file and some audio files, but it could be any other general purpose programming language that you could then run, perhaps in the context of some already existing implementation-specific framework that the generated code becomes part of. So again, to illustrate this, if I rebuild the voice menu, what I get is this textual file, which is the actual representation of the voice menu in the textual format. Now, that's not the only option you have. You can actually attach multiple generators to your language, so that not only you can generate this textual format, you could generate an XML that also contains the hierarchy of your menu, and using that, you could use that either as an input for some analysis tool that can analyze whether the menu is well structured, whether there's no, whether there's nothing too deep in the hierarchy, or whether none of the menus is longer than whatever criteria you might have, like 5 elements in a menu. So that, or you could possibly use this as an input to another voice menu system that you might be evaluating to replace Asterisk eventually. You might be generating HTML. In that case, you would be getting web pages documenting the structure, so that from the same model you would have the implementation generated as well as the documentation at the same time, perhaps overnight on a continuous integration server, so everything is automated and works beautifully. Now, last but not the least, you could generate Java code. Call here, just so you believe me, there's Java code generated, and the Java code generated could be run. So when I run it, I get a Java simulator simulating the voice menu for me. So I got this little phone, and I can now click through the menu. The phone talks back to me, giving me instant feedback, so I can simulate the behavior of the menu before I, let's say, commit to Git. Right?
Welcome to JetBrains. We're happy to choose from this.
Yeah, I'm not sure how audio gets transferred from me to you, so I will not go through the simulator, but here the simulation is part of this. So, well, why I was showing that? Well, the ultimate message of this is that you can have multiple generators attached to your language, and you can generate various outputs. So the generators, they detach the model from the implementation domain. So the implementation domain tend to change more frequently than the actual problem domain. And so you might need multiple generators either at the same time or gradually as the implementation needs to change, more organization. All right, so that was an example, so that now you know what to expect from MPS, right? So this is an example of what you could do. Obviously, a simplified one. There's so in general, we created a modeling tool that serves for modeling in certain domain, and the modeling tool was created with a meta modeling tool with MPS. And so the promise MPS makes is that creating such tools and languages is easier when you do it with MPS compared to going from scratch. And how that's the purpose of this tutorial, how this actually can be achieved. Before we move to that, I've got two more examples of completely different languages so that you don't get stuck in your mind to this particular domain of voice menu definition, right? Because that's just one of many possible domains where MPS can be utilized. So let me briefly show you two more examples. So here is a chemistry domain. So here is a language that allows people who understand chemistry, unlike me, to create and type the chemical formulas. So, well, I just pretend I know chemistry. So I'll use so I'll take two elements of fulcrum, which is copper, I believe, and oxygen to it. And now we can combine it into whatever, something, some other molecule. So, the editor supports me along the way. So it gives me, code completion for all the elements that are available. Also, it gives me, again, domain-specific error messages. This time it tells me that my equation is not balanced. It tells me, that the number of copper atoms on the left side doesn't equal the number of copper atom on the right side. So I've got an error in my equation. So now when I prepend value 2, now copper is fine, but this time I believe oxygen is not right. So we have to add 2 elements of oxygen right here. So, you see a completely different language, but the principles remain the same. Well, and the last example I have, it's again a different domain. Now it's the domain of physics. So it might serve, concretely, it might serve for simulation or education in the physics or physical mechanics domain. So I've got here running a simulation with 2 balls. The one on the right side is heavier than the one on the left side. That's why it keeps bouncing for longer, because the air resistance will slow it down. It takes longer to take away all the energy from the ball through air resistance because it's heavier. And now the languages here allow you to specify such worlds, like I've got a ball, has certain mass, position, and some velocity. And there are some forces, like gravitation force, which you might define, some air resistance force, which has, again, it's computed in a certain way and has certain direction. And you might actually use that language to create alternative simulations, so you can compare the effect of changing a property. So we can, for example, in that bouncing world, we can change the collision reaction to an elastic reaction where some of the energy is lost in elasticity. Let's say we only keep 60% of the energy when the ball bounces. So now when I run this simulation, now we should see a different result. Actually, the heavier ball is now slowing down faster because it loses quite a lot of energy at each bounce. So this is more like a mathematical language. Actually, you can use math notations wherever you need to. And in addition to that, because this is physics, what is important for physics is physical units. So the type system of this language has been enhanced to actually support physical units. So two integers or two numbers are not the same if they have different physical units, which is something specific for this domain. In general purpose languages, you don't actually get that distinction. A double is a double, no matter whether it holds weight or distance. So here I've got initial velocity, which is specified in meters per second, but there's alternatives. I can have 10 kilometers per hour. That's also a speed physical unit. However, if I say 5 kilograms, then obviously the type system is now not happy because kilograms can't really compare with speed. Now, however, if I say, let's say 5 astronomical, if I say 5 astronomical units divided by 3 centuries, and we are back to business. Now, this is speed, right? If you take distance divided by time, you get a speed physical unit. So the system implemented in this sample language is pretty robust in terms of physical units. In fact, it allows for each physical unit, like what we call dimension, like for length, we've got physical units, with one of them being the sort of the main, and then you've got conversion ratios for those. And similarly for the for time and mass and speed as well. Speed is obviously a little bit more difficult because it's calculated from length and time, but still it's possible to define it and use it this way. Okay, well, so this was the illustration of where MPS can get you. I mean, what kind of languages. Now, right, okay, so, but these were more like artificial examples, obviously just showing some particular features of the tool. Well, in reality, MPS is being used by several users, both in industry and in academia. It's not the purpose of this video to actually show all the examples. I mean, there are other videos, we list them on our website. So if you're interested, you can, certainly there are places where you can learn those. So I don't want to really spend much time on that. The only 3 I would perhaps briefly mention here. One of them is Dutch Tax Office, who use MPS to codify the tax law in the Netherlands. So they could have finance experts who understand tax law to actually directly write law logic in their models, so that they can have systems that calculate taxes automatically. Then Siemens has developed domain-specific languages to formalize their contracts and subcontracts, so they can actually simulate the cash flow for the contracts that they are signing with their customers, so they can pretty quickly providing and formalizing the client requirements and taking into account the the formal specifications of their subcontracts that they want to employ on that particular case. Or they can get instant feedback whether they can actually provide the guarantees that the client wants and what would be the cost. Well, a third example, medical software. When you write software that is supposed to actually help people and treat people with some disease, and tell them when and which kind of medicine to take. So this software has to be approved by authorities, because obviously it can cause harm, just like medicine can. So in order to certify the code of these applications, the rules the application is based on, they have to be actually understandable to people who are not programmers. So they have to be written in some high-level language that is that the doctors are able to actually certify. Okay, well, that was about the example, so that you don't get a feeling that this is just a toy thing in which we do examples. It actually can serve real purposes for real clients. And now we're getting to the business. Now we're getting to the actual, how MPS works, how things are defined. And we'll take it from the beginning, right? As when you define a language in MPS, you have to do several things. You have to define the abstract syntax. You have to define the concrete syntax, and then various constraints and type system, data flow. Obviously, the generator, one or many, and perhaps also the tooling, the support you want from the editor. Like you might support some refactorings. You might want to version your language as your language evolves. Or you might provide some intentions to the user or code analysis. So we'll cover those gradually. So first, let's focus on the abstract syntax, right? Abstract syntax, as most of you know, right? That's how the code is represented for the computer, for the compiler or for the editor. So the code that is displayed on the screen is somehow abstracted into a tree structure on which the editor and the tooling can work. So to set the terminology right, how we do it in MPS so that we understand each other during this tutorial. Now, so this little tree starts with a root node, so the node that has no parent, that might represent in Java, let's say a Java class, that is called a root, and it has children. These children then obviously can have a parent, and then the children are in roles. So an if statement has 2, maybe 3 children, an expression that is in the role of a condition, and then statement list, which is in the role of a body, and then maybe another statement list, which is in the role of the sort of false body. And then you might have references that point across the tree or across multiple trees from, let's say, a method call to a method definition, or variable usage to variable declaration. So, for example, an if statement, right? If you declare an if statement, if you were writing a compiler, let's say in Java, then you would represent an if statement as a Java class, and you would leverage inheritance of Java. So perhaps if statement is a special case of a statement, so it would extend statement, and then if statement would declare 3 children, Boolean expression for the condition, and 2 statements. In MPS, we have a language that is inspired by object-oriented languages that we use to define abstract syntax. So the language to express the structure or the abstract syntax of a language in MPS looks very similar to any object-oriented programming language. We call those things concepts. So an if statement would be a concept. And again, it might extend some other concept, maybe an abstract concept that is common to all the statements in that particular language. It might implement some concept interfaces, but this language is not this structure language is not a general purpose language like Java, so it can be specialized. It doesn't have to allow writing all kinds of application. It's only designed to define structure of a language. So apart from the inheritance, it is then very specific to what is needed from a language for defining abstract structure. So it has a section where you define the properties of that particular concept. So what values, what scalar values can be part of an instance of this statement. The instances of a concept, we call them nodes. So sometimes I'll be using the term node, sometimes an instance of a concept. That's sort of the same thing. So nodes can have properties, some scalar values. They can have children. So here you define the possible roles for children. And then obviously children can be of certain concepts and can have certain cardinalities. Well, and then you have a section where you define references. So if you want a pointer from nodes of this concept to some nodes of some other concept somewhere else. In addition to that, you have some helper information, like can nodes of this statement be roots? So can they live without a parent? For an if statement, obviously it doesn't make sense, but perhaps for a class definition, it could make sense. You know, if that could be allowed not to be a root. Alias is a shortcut for how to recognize the user actually wants to, you know, to insert an if statement. So perhaps how to represent an if statement in some completion menu so the user can easily recognize it. Okay, that's an if statement, I want it. So, you know, that's a structured language. So in essence, you know, models or source code, or whichever way you want to call that, in MPS, they are trees composed of nodes, and each node is an instance of a certain concept. These concepts, they come from the languages that you employ in your models. Now, I want to get concrete here. So not only talking about, you know, abstractly in about an abstract syntax, but I want to give it some concrete example. So let me switch to the right example. Here we go. So we'll be using this little language here for our experiments with MPS. This language is part of MPS distribution. So if you install MPS, you have it. So that helps if you want to learn MPS at some point. You have a starting point. So the language is, well, this robot language is a language that allows you to command a virtual robot. So you write a script that when you run it, it will create a Java application, a Swing Java application that visually illustrates the robot walking around some, you know, some maze or some place that you might also define. So typically it's a rectangular area. There might be some elements, and the robot will walk around, detect walls, and, you know, pick up the elements or maybe drop some elements. You know, I was inspired by a language that is used for teaching people how to program. So the basics of algorithms. In that language, what you can actually tell the robot is to, you know, to make a step forward, maybe to turn left. You have an if statement, and the condition can detect whether there's a wall ahead, or whether you're heading south, north, or, you know, some particular direction. Apart from that, you have a repeat statement, so a fixed number loop, and you have a while, which loops until a condition is met. And I think that's about it. Additionally, you can define your own routines. So you can define a routine, turn right, which would perhaps look something like repeat 3 times, turn left. So really a bare minimum language with some abstraction built in it, where you can use to build the new and higher level abstractions. And the code is generated into Java. So now if I ask the generator to generate Java for me, so here is the code that gets generated. So, you know, we don't have to go through that. The Java code actually that was generated, this class, extends some other Java class that is part of the framework that is provided. So it's not generating all the code. There is already code that has been pre-prepared as part of a library. You know, it could have come from a jar file, or I just made it part of the solution here. So it's some class that is not generated because it's always the same. So only the thing that changed, and that is the sequence of commands to the robot, that's what gets generated. But the thing that stays the same, the actual runtime and visual library, that is not generated. And since we are talking about the abstract structure, Now, this is the definition of the repeat statement, the repeat thing that we have here. Repeat 5 times, whatever, I'll just give step in here. So the definition of that repeat in the structured language concept is called repeat. It extends abstract command, which is a common statement superclass for all statements in this particular language. So anything that can appear in the script here, all these are concrete sub-concepts of the abstract command concept. So alias of this repeat is repeat with lower r. It has a property count, so that is the number here, that's a property. And well, children, we only have one child role called body, which holds a command list. And if I look into command list, that's a concept. Command list, again, extends abstract commands and has a child commands, which is a list of abstract commands. So what we'll be doing here to illustrate the principles MPS allows you to create languages. I need to organize my screens here. Good. Okay, so what we'll be doing is introducing a new command called jump. Right? It's not part of the language at the moment, so there's no command jump. We want to make a jump, and so that the robot makes a faster move forward. So not like step. That's one step ahead. We want to make 3 steps or 5 steps, or basically make it to make more steps. Now, first, maybe the language allows the users to enhance the language themselves. Many languages come with abstraction, support for abstractions built in. And this language is an example of such a language. You can create a routine. You can call it jump 5, and define that this means repeat 5 times. If not, go ahead, make a step. So I've got a routine that actually makes jump 5, so I can call it. And if I run this, I hope it will make 5 steps forward. Oh, it started on another screen. Okay, but anyway, it started on the left, in the left corner, and made 5 steps. So definitely it works. Okay, so yeah, if all I want is to make a jump 5 command, I'm good. I can do that. The abstraction built into that domain-specific language allows me, without asking the language author to update the language. However, for the obvious reasons, I can't do jump 3. Or, well, I can, but then it leads to duplication, because the abstraction here doesn't allow parameters to be passed to routines. And without parameters, I'm not able to generify the routine into accepting different values as parameters. So I can't do that. So really, there's no other way than I have to ask the language author to add an extra command for me. Or I can actually do it myself, even though I might not be the original author of the language and I might not have access to the sources. Obviously now I do, right? I've got the language robot defined right here, but I could have just downloaded it as a plugin into my IDE, and then it would be read-only for me, like many other languages are. There are many languages that come bundled with MPS, and other languages you can install as plugins. And those you can't modify directly. They have been compiled, defined and compiled by someone else. So if you want to make changes to them, you actually can't. But you can create extensions to those languages. And since this is really the case for an extension, I've got an existing language and I want to extend it with new capabilities. So I can do it without touching the original languages.
Vaclav, just a very quick note. There was a question on the chat, and which has made me realise that you're probably not actually seeing this while you're giving your presentation, and so
right.
I've just jumped in briefly to alert you of that. I think we've highlighted it in the video as well. Avi has asked whether the resulting models that are produced with MPS would be compliant with OMG's MOF definition, MF definitions. Yes.
No, it wouldn't. I mean, the model that we have is really our proprietary, formats, and at the moment it might be perhaps exported into other formats, but internally it's proprietary. Well, it's not hidden as such, right? It's no secret, the structure of the model, but it's not compliant. Yeah, I'm sorry, I can't really. I can either pause this to check the chat, or I will rely on you, Stefan, to tell me.
Absolutely. I think what I'm suggesting what we'll be doing is that Nuno or I will just pop on the stage if there is a question that comes up which looks like it would benefit from being answered more or less directly. And then we'll just sort of interrupt you briefly. Would that work okay for you?
Perfect. Yeah, that would be awesome.
Excellent. Let's do that. Then I'll just pop off the stage again now and be back if there is another question.
Okay, great. So we can actually create our own language now, assuming we can't touch the original languages. So I'll create a new language. I'll call it jumps. So a new language is now created. And since I want that language to extend the robot Kaya language, I declare that in the dependency. So that's my new language will extend this Kaya language with some new constructs. Well, and here we see a structure of language, a new empty language that doesn't do much. And you see inside that language, you've got these colorful models that each represent a different aspect of the language, like the abstract syntax, concrete syntax, constraints, some behavior associated with concepts, type system, and then the generator. And there's a lot more you can actually enable on demand, right? So add some other aspects that are not visible by default, but you might pick them from here. Like I will be needing intentions later, so I'll just add them now. So we've got an empty language here, and now it's time to start with the jump command. So the the context, the jump will become one of the commands, so it definitely has to extend the abstract command just like the other commands do. And it will hold a property that will hold the number, how many steps you want to make as part of that jump. So the declaration of that jump concept will look like that, right? We give it a name jump, we make it extend abstract command. We might give it an alias jump so that it's easily identifiable in the completion menu, and we need a property number of steps, and that's about it. So let's do that. So in the structure aspect, I create a new concept called jump, a command, then the alias will be jump, a number of steps is a property, and it will be an integer. So I've got a concept. I can rebuild my language. So my empty language now has one concept. And let's see what effect it gives us. So now I go to the sample here. And well, one thing I have to do, I have to import that language, right? The important thing is here, not all languages are always visible. You specifically indicate which languages or the extensions of those languages you actually want to have available in your model. So not all extensions need to be visible. It might be overwhelming if you have if you add all the languages that are part of the of the installation of MPS and all the extensions to them, if you make them available all at the same time, sometimes some of the extensions don't really make sense for you. Like, for example, this robot Kyle language has extension for logical operator and or, and it also has extension for scene construction, where you can actually build the scene, like add walls before the robot starts moving through the, or you can actually add them as the robot moves through the area. So maybe that scene construction language is not always actually necessary. So in that case, you don't include that, don't import it, and your namespace and your code completion is not polluted with constructs from those languages. So for jumps, I have to import them. So now this language is part of my set of languages that are available in this in this code, and I can choose jump from the completion menu, and here's my jump. I can delete this routine here, it's no longer needed, and I'll delete those as well. So here is my instance of my jump concept I've just created. So here's a node, jump 5, and I can create another jump 3 times here. So my abstraction is now capable of handling jumps of different arguments, different number of steps. Obviously, we're not all the way there, right? But we've got the abstract syntax. That's a good start. And you see, it looks tree-like, right? It doesn't really look like, the other commands in this language, right? They definitely look nicer. So that's the next. That's the next task, to make it look nice. So we have to look into the concrete syntax, right? The computer or the editor, it doesn't really care how you want to look at the code, but we programmers, we do care. We care about how the code looks like. So there's various kinds of notations that have been in use. There's the typical one for regular programming, textual notation with maybe some indentation and block structure in them. There might be some symbolic notation, some extra symbols like mathematical symbols, for example, that are nice to match with text. Tabular notations are very popular, either spreadsheets or it could be various state machines and these kind of things. And also graphical notations might be useful at times. So there are different notations. It's not that you would like to restrict your tool to just one, right? That all of them might be needed, or for different domains, different might be needed, or different combination of those might be needed. So we've got actually users of MPS that use all of those notations. I mean, not at the same time, but we've got users that use different. So all of these kinds of notations are utilized by some of our users. So, the notation is very important, especially since the users might not be technical people, right? You might, with domain-specific languages, there's this extra additional risk that you might not invent notation that is telling enough to the domain experts of that particular domain. So you should follow the constraints and the the way people do or specify code in their domain. You should follow those and reflect that in the notation. So we have to distinguish between the abstract and concrete syntax. Obviously, there is a mapping, right? Mapping that maps the structure to the editor, so to the screen and back. So it's just a way, different way of looking at the abstract syntax, how to lay it out on the screen. So back to the example of a repeat statement. So repeat on the screen should look, I mean, the idea was to have it look like in Java, some sort of loop statement. So the definition of the editor in MPS uses a dedicated domain-specific language that allows you to specify cell by cell what should be displayed in that particular area of the screen. So if our jump is to look like what you see at the bottom, jump 5, then in the editor definition, you declare that this way. I say there's the word jump as a keyword, and then next to it is where the property number of steps should be inserted and allow editing. So let me first do that. So I do the jump, I go to the editor, and well, so we'll say jump, and now number of steps. So 2 cells, one which is a keyword jump, and one number of steps, which holds the property. If I rebuild that, now we see jump 5, jump 3 is right here, and jump whatever editing experience is something that we would perhaps expect. Now, maybe I would like the color to be the same as is in this command step. So let's see how the editor of step does it. All right, so the particular cell has a style attached and which changes its color. So if we do the same for jump and say style of this should be command, how this particular cell changes the color, so now it's consistent with the with the original language. Now, speaking of the editor, there's one thing that needs to be mentioned, right? The editor is projectional. Many of you probably know that. So the interesting. So the editor here is not textual but projectional. So instead of editing text and then having the editor reparse your text, there's no parsing in MPS. You're editing the tree directly. So what you see on the screen is a projection of the tree. So that's why the editor sort of maps the tree, the abstract syntax tree, on the screen somehow. And not vice versa, that we would define, here's some text and we have to parse it to build an abstract syntax tree. Right? So that goes slightly, somewhat in the opposite direction. So we map the task of the editor is to map the abstract syntax elements onto the screen. And then the model is persisted in this structure, in this tree structure. So it's an XML document that is saved on a disk and also, and then loaded into the memory and then worked on. And then the task of the generator is to transform this model and then eventually perhaps generate text which can be then parsed by a compiler. If that's the output you desire, you desire some sort of general purpose language that has a compiler, then this is the scenario that you would follow. Now, so what this means in reality is that when you type code, it's not really typing text, but it's more like triggering events on the editor. So the code at the bottom, you've got a variable declaration, initializer is 1. So the initializer is represented by a little tree, integer constant, value 1. And now you type multiply and add 2. What happens is that it's not that you type this and then the editor would somehow parse it using some rules. No, it's that the typing multiply followed by a number triggers an event, and that event understands you want to insert a multiplication, and that the left child should be whatever was there before, and the right child should be the thing you type afterwards. So you get, a tree, and then it's back projected onto the screen, so you see 1 times 2, as you would expect. And so you could continue +3, typing to the right performs what we call right transformation. So the code gets transformed as you keep typing. If you go to the left and start typing to the left of some element, then it's a left side transformation. Just same principle, just opposite direction. So all keys you press trigger an event of that on that particular cell, and then it's up to the editor to actually handle it somehow. So as a result of that, sometimes some events are not really handled. So if I put my cursor inside a keyword like here and start typing, nothing's happening, or inside repeat, because there's no event handler associated with typing a character. You could associate one that would perhaps tell the user to stop doing it. But other than that, there's no meaning typing in the middle of a keyword. so it's not allowed here. And also, if I hit backspace right here, it will delete the whole repeat, not just the D, because it's not really a per character editor, it's like per node editor. All right, now here we go. So, the obvious benefits if you don't have a parser is that you can have syntaxes that would be difficult to parse, like, tabular notation of various kinds, be it spreadsheets, be it state machines. You can have symbols expressed like, images in reality that are used together with regular textual notation. You can have positional notation, so you can simulate, forms or Microsoft Word forms in which the position where you type things matter. So you can have like, sort of, you are filling a form, but in fact you're creating a model. And you could have multiple notations. That's another benefit. You could have, the visual aspect is secondary, right? So you could choose which one you prefer, and you can switch between them. So you're not stuck to one particular notation. So you could have textual, tabular, modular, graphical, all attached to the same tree. And you could choose which one you use for coding, which one for code review, which one for merge conflict resolution, if it makes sense for you. And switching annotation is just a matter of, let me show you here. So here I've got a simple language for workflow definition, where I define some states, events, and transitions. Well, and I can change to a tabular notation, and now this thing is a table, and I can, edit it here. And then when I'm done, or when I prefer going back to structure, I go to structure. The event is there. It's just, editing the model using different notation. Sorry. The presentation software sometimes jumps to the beginning, so I'll just fix that. Right. Okay. When you define, just final words on notations, right? When you define notation for a language, you have to weight various qualities of that notation. It could be either learnable or productive. Like, learnable notation is one that you can easily understand, but might be quite chatty, so it might be less productive than some notation that is that doesn't use that many words. On the other hand, if that language is supposed to be used only from time to time, like once every year when you have to fill in your text form or define some text form or whatever, then learnable notation might be more beneficial. With the ability to switch notations, you actually don't have to make that trade-off, right? You can have a notation that is learnable, you can have a notation that is very productive, and have different users use different notations, although they edit the same model underneath. Similarly, for writability and readability, you might have notations that are very easy to type, and you might have notations that are very intuitive to read, like maybe graphical notations might tend to be on that side. But yet again, if you can switch notation, then you don't have to make the trade-off to make a notation that is both writable, readable, or more writable than readable. You can have both, just different notations for the same model. And you can combine languages. That's another benefit when you don't really have a parser, because combining parsers is a difficult problem. So having the ability to mix and match languages, at least syntactically, the projectional editor makes it pretty easy. Obviously, there are other aspects, like type system and the generator, where you have to pay a lot of attention to how you define your language that is meant to be combined with other languages. Okay, so eliminating parsing gives certain benefits that are just illustrated, but we should probably get back to the concrete example we have at hand. So now let's look at the generator, because that becomes really interesting. You already know the robot language gets generated into Java. So we've got Java source that we can then run Java compiler against, and we've got Java runtime to run it. Now, MPS is not a textual tool, so we can't really have Java as such and textual Java. But what we created is a copy of Java we call base language, which is basically a clone of Java, but defined using the MPS terms, the concepts, editors, and other things. So we created a long time ago a copy of Java called it base language. So you can actually write a Java in MPS. You can use Java as a Java editor. So this is it. So I can do some typing, but this is not Java as such. This is again projectional Java, right? So this is base language. So the editor is projectional. I can have a look at the piece of code as if it was a tree, right? So now this method is now displayed in the tree form, suppressing the editor. If I press backspace here, I delete the whole method. So this is not, a textual editor. This is a projectional editor editing Java. So we've got this base language.
Vaclav, apologies for interrupting you. We have a question from Joe Habgood. Would this be a good time?
Yeah, right. Yeah. If it's related, then sure. Yeah, I think it is, right?
How does projectional editing work when you have a model that is edited by many users? Example, do they have to lock the models to avoid conflicts, or is there a way of merging edits like you can with textual source code?
All right. Yeah, good question. Now the models are stored in. Perhaps I'll find an example where this would be nicely illustrated. Let's see. Right. Okay. The models are stored on disk in XML files, and you use the usual version control systems you would use for for programming, like Subversion, or we prefer Git. So it's using optimistic strategy. So when you make changes, you just work just like basically you work with Git on your local copy of the central or some repository. Then you might commit to your local repository and push to the central repository. And if there are conflicts, you resolve them. You resolve them in the IDE. The tool has its own viewer, so that you can resolve. I'm just trying to see if there's a good example. Some code I've changed. Okay, well, I'm not able to illustrate that here, I'm afraid. But the thing is, you just work in your IDE or on command line with Git, and if there is a conflict, you resolve it in the editor. You get a pop up with with the editor. So you don't resolve it on the XML level. Obviously, you resolve it on the syntax level. So with the projectional editor, so you see two projections on the left side, right side, and you compare the versions and resolve the conflicts. And you're done, right? So it's we're not having our own model storage and cooperation resolution thing. So you work on the model. You have a sole. I mean, the code you work on it on your own. I mean, you can't really share it with others. There's no cooperation on the model as such, other than you can commit and push so others can see it. So does it answer the question? All right, good.
Thank you.
Okay, so we've got the Java source as the target, base language as the Java copy that we have in MPS that you can actually use to write code. But typically, you create some sort of languages that generate into base language, and that's the case here. We've got the robot language that has a generator already that can generate the base language. And base language then has just textual sort of generation where it flushes the tree into a text file so that Java compiler can take it from there. And what we have now created is the jumps language, which extends the Kaya language. So we have to hook into the model-to-model transformation thing, and we have to go in stages. So first, the jumps language has to somehow generate into the pure pure Kaya robot language. And that one already knows how to generate into the base language with some closures and collections extensions, which know how to generate pure base language without closures and collections extensions, and that can then be flushed into text. So, in MPS, the generators work in cascades, so it's not like one gigantic generator, but it's more like sequence of generators, each sort of lowering the level of abstraction until you get to a model that is then suitable for textual transformation. So back to our example, we've got a tree the model where there is a jump, but we don't have so now we have to replace jump during the generation, during the first phase of the generation, into a repeat 5 times, if not wall ahead step. So basically we have to lower the syntactic level. And then the generator that is already present in the robot language can take it from there and continue. So let's do that. Here. Right. So we'll go to the generator of this jumps language, and we'll add a new reduction rule that will replace jump with a new template. So now the code that should be generated. So we should generate a repeat if not wall ahead lose step. So this code is the code we should generate for our jump, apart from the value 1, right? Value 1 doesn't really make sense. But we don't know what value there will be, right? There's here's 5, here's 3, so that value can't really be hard-coded. It has to be extracted from the jump. So here we use 1 just as a placeholder, but we specify a property macro that will replace it with the actual number of steps of that jump that we are generating code for. So from the input model, we take that value, we remove jump, and insert this little tree instead. I mean, this is abstract syntax tree, right? It's still projection editor, not textual. Right. Okay, so with this rule defined, now let's see if this really translates into jump 5, jump 3. So let's see if this has the desired semantics. So I'll run the code, move it in. So it should be 8 steps altogether. I think it is. So it seems to work. Now, if you look at the generated code, the Java code that gets generated, if you look carefully, you will see there's a for loop here that iterates 5 times. Here's a for loop that iterates 3 times. So hopefully it is generating the right thing. But hopefully it's perhaps not the right sort of state of mind. We should be sure. So we can ask MPS to give us an insight into what gets generated. So if I regenerate again, now with this extra option on, I can now see through the steps that the generator has made. So here's all the steps the generator went through. So it started with this code. So this was the code I typed. So this is the model that it transformed. In first it translated into this. So here we see that our rule works correctly, right? We started with this, we got that, which then went through several other stages. That's not really interesting here until we got this base language code that then gets flushed into text. So this allows us to look into what the generator is doing. And we can actually navigate even back and forth, right? If you look at this for loop and you're interested how comes it is in the generated code, you can trace it back. So you can see that this code was touched here in phase 0 to phase 2, when it's originated from this code and using this reduction rule, and this template was generated into this repeat. And then later on, this repeat using this rule was generated into this for statement. So yeah, so we can, this way we can inspect what the generator was doing. I think that's very useful when you're debugging the generator. So that's why I'm showing it. Okay, but we've got more to cover. So let me switch back to here. Okay, so there are more things, right? The abstract syntax, concrete syntax, and the generator are essential, that for the language to work. We might argue that concrete syntax is not that important. That's at least in the prototyping phases of some languages. If you are happy to look at the tree-like abstract syntax on the screen, then fine, then you can live without the editor. Now, there might be constraints that you can define. So, for example, you might want jump to only go forward, so the value should only be, non-negative number. No problem, you can do that easily. We just add a constraint to the jump. So in the constraints section, we might go to the property constraint. The property is number of steps. The property value is only valid when it's greater than 0. So now when I make the value negative, it is rejected. So well, that was easy, but let's try something more interesting. And now we'll touch the ID support. So there are many things the ID can actually do for the language. Various kinds of intentions. That's in the MPS terminology. These are like suggestions to the user. Hey, you could perhaps change the code like this or that. You might have refactorings. You might enhance the ID itself with extra menus and extra panels. And there are many other things. So let's try some code analysis first. So let's detect that there are two jumps. There are two jumps in the code, and they could be joined together into one jump, like here. Right? If there's some command in the middle, then you can't do that. Right? But if there's just comments or some comment or some empty line between them, then fine, they can be merged. I'll add one more jump here, and with some command in between, just to distinguish these two cases. So code analysis can be done through the type system at the moment. So we'll go to the jump command, go to the type system, and do a check-in rule for jump. And now we'll go jump the previous sibling. So what I'm doing now is programmatically I investigate the code in the tree form. So I'm basically going through the tree and see what is in there and read or change values in there. So I go to all the previous siblings where it is not an empty line, and it's not an instance of comment line. I get the last of those. So that previous command is instance of jump. So there's a jump right ahead. You can issue a warning or an error or whatever you consider appropriate. Sequence of jumps in here. So let's see if that works. All right, so here it says a sequence of jumps. So it detected that there's a jump ahead that it could be possibly unified with. It doesn't report it here because there's turn left between. So obviously these two shouldn't be unified. But we could also define a quick fix that can be useful for users. So they can merge these jumps. So we need to know about the one that was discovered as the previous one. So we've got the previous one, description for the user. And copy the number of steps to the previous one. So we take the number of steps from the current one, copy it into the previous one, and we can remove the current one because then now it's not actually needed. So this is a quick fix, and the last thing to do associated it with a warning. So here we say merge jumps, and the previous one will be the previous command cast to jump. So now we have a detection of a problem and a quick fix associated with it. So that now when here is this problem, we have this light bulb show up here offering us, merge the two jumps. And now you see this is jump 8 and that one disappeared. So that was code analysis with the possibility to quickly fix an issue. So another possibility, what could be useful, is an intention to suggest the user to do something. It's very similar to these quick fixes, in fact, but they might not be reacting to errors. They might just be suggesting changes, refactorings, whatever. So let's try one intention that will detect that there is in your code a repeat that matches this pattern. So you have a repeat several times. If there is not wall ahead, make a step. That's exactly what a jump does. So we might have an intention that actually suggests the user to replace such a thing with a jump. So intentions, they have their own aspect here, their own model. So I'll create a new intention here. Replace with a jump or a repeat statement. So replace with jump and count. So we take how many repeats you want, and jump will have the same number, right? So we can actually use it in the description for the user. Now, should it be authored for that repeat? That's its applicable function. Will say for this repeat, yes, for that repeat, no. Now, here is the place where we have to detect whether there is a match, whether the repeat is actually suitable for being replaced. So I need a couple of imports here. And now I can use the pattern match statement, so that now we will match node with pattern condition. So we'll do a repeat 1 times. If not wall ahead, step. Now we want to match repeats no matter how many, whatever the number here is. So this will be replaced with a variable. So we don't really care. So we don't really care for.
Just a quick note, Vaclav, you've got
go ahead.
like you've got something like 7 minutes or so left in the session. So just about.
Yeah, thank you. No problem with that. I mean, I'm almost finished here. So
yeah, good, thank you.
So we've got the repeat. We've got some local sort of name that we could use, and now, so if that matches what we return, and we might return true, we discover the repeat, or actually we might be more picky. We might say only if the number is bigger than 0, right? Only if the number is bigger than 0, so repeat will be can be replaced with a jump. By default, return false. And now what should actually happen when the user chooses to? Well, no.replace with new jump. So we'll get that jump, and number of steps will be node.count. We copy the number from the repeat into the jump. So we'll replace the repeat with a jump, copy the number, and we're done. So let's see. I'll do repeat 5 times. If not, roll ahead, do step. And we've got a suggestion to replace with a jump. And here it is. If the value was negative, then it's not altered at all. And if we replace this with turn left, and again, it shouldn't match, so there's no suggestion to actually replace it. So let's back to here. All right, so that was intention. You see, we could match code and we could replace it. Again, we were manipulating the code, reading the code, checking the values, and replacing. The last thing I want to cover, but perhaps without an example, because that would just take time, that's not really perhaps necessary in here, is language evolution. I think that's an important aspect of language engineering. You can't expect people to get the language right the first time. So you get a version 1 of a language and people start using it. And then you evolve that language, and now you want to distribute that language to your users, but they've already built models with the first version of your language. Now they have to safely migrate to the new version of the language. There are many kinds of changes you can make to a language, especially, in MPS. You can add new concepts, you can add properties, add children references. These are all fine as long as you keep adding things to the language. Well, then you don't really break models of your users. But if you remove a concept or you remove a property, now you've got models that still use that thing that you've removed, and now you've got broken models. So this has to be done carefully. The same if you introduce a reference that is mandatory, or new child that is mandatory. And obviously the existing models don't have that reference set, or they don't have the children set. So you've got broken models. The same if you tighten the constraints, right? In the first version of my language, jump allowed any value. In the second version, it only allowed non-negative values. So all the models where the value was negative now immediately became invalid. So how to cope with that? Well, so the scenario, right? Someone uses version 1 of your language that you've distributed earlier. Now you have a second version of that language that you distribute. So what MPS does, it actually keeps a number in each language, like what version of a language it is. And if you make a change that needs some special care, you actually introduce a new version of that language, and you provide automated migration script that will run automatically as soon as someone imports that new version of a language into the model. So you have it as a language author, you have the chance to migrate programmatically your user models from the previous version to the new version. And if you want to remove things, well, you should perhaps adopt the deprecation sort of idea. So you want, for example, you want to replace a concept with some new concept. So you introduce that new concept in your version 2 of your language. You mark the old one as deprecated, so that people know it's deprecated. And then you also disable all the ways the old concept could be instantiated. So you remove it, you remove all the intentions, code completion menus, so people have no way to actually add it to their models anymore. And you add a migration that removes the old instances, the deprecated ones, and replaces them with the new ones. So this way, well, the old concept is still present, but it's not really in the model anymore. And in the next version, you could perhaps remove it altogether. But you have to keep it at least for one version so that the migration can actually safely migrate the code. So here's just an example of such a migration that would be very simple to do for our jump, which we will not do in the code. Basically, this would, basically the code will go through all the models, detect all the instances of the jump, and update them, right? So essentially, it's basically a script going through all the models of the user code, touching the instances that needs to be touched, and does the necessary changes to them, be it adding new children, replacing them with some other nodes or concepts, and such. Okay, I think I exhausted the time I had for my presentation. So that's all I actually prepared. So I'm happy I managed to go through all the examples I wanted to show you here. I hope it was interesting and relevant and enjoyable. And I think we still have some time for questions, so I'm ready to answer them. So are there any questions? I haven't really looked through the chat, through the comments yet.
Yes, well, Vaclav, I believe there are no comments. I was making a brief pause to understand if there were any comments, but I guess there are not.
I agree. Yeah, I also don't see any unanswered questions there.
Yeah, so maybe we can conclude our tutorial. I would like to thank you very much for this enlightening tutorial.
It was my pleasure.
We will now have 1 hour for lunch, and then we'll be back for the challenge talks and success stories at 2:30. And after that, we still have time for a speaker talk by Balby Barn on digital twins, ending with the networking coffee break. So thank you very much, everyone, for attending, and I'll see you in an hour.
Goodbye.